Hi, welcome back. We're talking about Centrify Privilege Service, component of Centrify Infrastructure Services, and this is the customer-hosted version. The whole topic is around high availability. We've done many scenarios so far. In the previous video, we talked about software failures in which the dependent service is the web service or the database service. Based on the policies defined on failover cluster, we could predictably know what there was going to happen in the cluster. Now we're going to talk about hardware failures. And in this environment, because it's inherently flawed, it's very easy to cause multiple failures at the same time. My systems are connected via iSCSI, and they only have one NIC card. So when you look at the validation reports, it's quite important to understand the meaning of some of the warnings, right? So I was warned when looking at the network connectivity that there's only one network interface, right? So typically in the real world, you would have a dedicated interface for network communication, heartbeat between the clusters, and possibly also your storage. So at this point, I'm going to take advantage of how flawed my design is, and I'm going to go into my member 4 machine, and let's just, before we do that, let's review the policy. So this system here, this role, which is the CPS role, depends on this. And when I disconnect the network, this IP address is going to be affected. So the policy is polling every 5 seconds, and if it fails within a period, it will try to restart it in the same node. I assume this is going to fail, but at the same time, I will lose connectivity with the disk, so this will basically trigger a automatic having to move this. So I'm going to go back to my system, and I'm going to go ahead and disable my NIC card, and I'm going to go quickly back to my monitoring system here. So within 5 seconds, my expectation is that this is going to start getting a little sad here, and as you can see, very predictive. It's trying now to move over the services to member 3, right? So, and again, there's deficiencies in my design, right? Ideally, multiple NIC cards and multi-path I/O and all that nice stuff, right? So, and this is where, as you can see, we can actually do the failover and all that. So let's take a look. We could take a look and see if our services are back. Here's the admin portal. And if I do an about, notice that I'm in member 3 here. So this proves that we can maintain high availability in case of a hardware failure like storage failure or a network failure. Another very dramatic thing that you could do is we already did a graceful shutdown of a system when we did the upgrade, the failure doing the upgrade, right? The 2-node cluster failed, and another cluster node was able to take over. But a very dramatic thing that can be done as well is the yanking of the power supply, right? So, for example, I'm in member 3. The equivalent of yanking the power supply would be something like, if I go VM here, power, right, and I do a power off, right? When I do this power off, it's not very graceful, right? But it's kind of like the same equivalent of that. And ultimately, my expectation, and again, based on the rules of my cluster, this may actually completely go down. Remember that when you look at the cluster here, the failover policy may have a certain number of finite things. I modified this, but ideally the defaults, which is n-1 over here, so that 3 minus 1 is 2, and this typically is 6 hours here. But in this case, it actually has failed over again to member 2. So this also proves that we can yank a server, and I'm actually going too fast here, but that I can yank a server from the from the network, and it'll actually look. It failed, because I've been doing too many failures. So if I want this to actually come up, I would probably have to start my application again. And um, but yeah, ultimately it's about not only understanding what the test is supposed to be and that it's going to be successful, but the behavior of the cluster, right? So based on all the testing that I've been doing in a very short amount of time, the expectation was that my cluster was going to go down. Um, but I'm starting it up again. It's happy, and if I refresh it, it should be fine. But again, it's about understanding how the policy on Windows failover clustering is set up, the test that's going to happen, and the expected outcome, right? Because that's going to have a lot of impact on the processes and the cognitive knowledge that the people need to have in order to support the solution. And I'm hoping that this series was useful for you.